Hello, Lab 4, sample and hold. Two main parts of this. The first one, I'm going to show you screenshots, video tutorials, and then get up and patch stuff, let you hear it. I want you to follow pretty much exactly what I'm doing so that you learn exactly what I'm showing you. That's part one. You'll make very short audio captures just so I can go check, check, check. Part two is you will use all of that information to get creative and patch whatever you want based on what I've shown you, make weird spacey sounds, and then you'll put them in Logic against a short video with a spaceman it's an animation. It's cool. I may have shown it to you in class on the 17th. I haven't made up my mind. I don't know. So we'll see what happens. So here's part one, sample and hold, number one. I want you to notice as I've set knob values. This is the Q110 noise module. Volume all the way up, that will never change. Sample and hold module, Q117. Input level all the way up, that won't change. Sample rate start off all the way up, that will change. Internal clock, the switch, that will change later. You're going to use VCO3 as an LFO, so set the range to low, set the frequency to about -1. Start off, and you're going to use the Q141 oscillator aid so that you can easily, quickly change waveforms. It's convenient. So set this to triangle to begin with, and set the volume of this all the way up. That volume output won't change. You're going to use VCO5 here as your audio VCO. Set the range initially to 4 feet, frequency straight up, so it's basically tuned to C. And then take this input right here, which is linear frequency for like vibrato inputs, and turn that all the way up. Come over here to the filter, turn the FM level all the way up, even though you're not using it at first. Turn the frequency all the way up, turn the resonance all the way down. For the VCA, have the switch in linear mode. I hope you know that it should always be there if you want to ask me about that in class. So that's all the initial knob settings. Now let's quickly do some patching. Here's what you're going to do. First of all, you're going to take a sine wave out of this, right into the audio input of the filter, low pass out in here. If you turn the volume up now, you should hear it droning as a sine wave, kind of dull sounding. And because it's not receiving a pitch input control voltage, it's not going to be a super high frequency like you might expect when it's tuned to the 4-foot range. So that droning sine wave is, you don't have to record that, okay? But just turn it up, make sure it's working. Then take the positive output of your LFO, and you're going to bring that into the input of the Q117 sample and hold module. Then take the output of the Q117 sample and hold and plug it into the linear frequency input. Come back over here and turn this up, and you should be hearing a pitch modulation that goes. Put Logic into record, capture a few seconds of that so I know that you did it. This is what that sounds like. Here we go. Now what you do is you slowly turn down the sample rate on the sample and hold, 8, 6, 4, 2. Listen to what it does. Then change the output waveform of the LFO to ramp, a rising sawtooth or ramp. Turn the volume up. Do the same thing. Make a quick recording of those two things, and then we go on to sample and hold number 2. Okay, there in part 1, the signal we were feeding into the sample and hold would be considered a coherent signal because it was a repeating waveform, either a triangle wave or a ramp, over and over and over. So as the sample and hold fired, there was always a predictable series of outputs. Now what we're going to do for part 2 is very simple change, and we're going to feed the sample and hold with an incoherent input. This is wicked simple. All you do, leave all settings the same, is you take, instead of the output from the LFO, you plug in the pink noise output from the noise generator. Then turn the volume back up and do the same thing. Slow the sample rate down and listen to how random it is. Then make a quick recording of that. a lot more noticeable with a waveform other than a sine wave. If you want, go to a sawtooth. Now we go to part 3. For part 3, instead of modulating or changing the pitch or frequency of the oscillator, we're going to modulate the frequency of the filter. These 2 steps that I'm about to do will require you to play around a lot more with the settings on the filter to dial in what it's doing. So this is what you do. Start off, return the input for the sample and hold back down to the LFO. Set it back to triangle wave, full volume. You haven't ever changed the speed here. But what you're going to do is, instead of feeding the output of the sample and hold into the oscillator to control its frequency, you're going to come into the FM input of the filter. Now you're going to change. Well, I actually marked the wrong filter here. Well, you get the idea because they're both the same filter, so don't bitch. So I'll move these over. So for all those experiments, you weren't using this but had it all the way up. This was all the way up and the resonance was all the way down. For this step, what you're going to do is bring your frequency and you down to 5 and your resonance up to 5. So they're both about halfway. Bring this up and you're going to hear the effect of that slow LFO on this. Now you're going to really need to adjust not only this attenuator for the FM level, but also the frequency itself and maybe the resonance to really hear the effect of what that's doing. I want you to do that, and then while you listen to that, change the waveform of your LFO to a ramp so you can hear it going up or a sawtooth going down, your pick. Then put Logic into record and capture a little bit of both of those, the triangle and the ramp, with me hearing that. This is what that sounds like. Something I forgot to mention is that you will hear the effect of this a lot better if you switch this from a sine to a sawtooth wave. So have the audio output be a sawtooth instead of a sine for this step. And this is what it sounds like. Remember how I said you had to make a lot of adjustments? I think I'd bring my audio oscillator range down to 8. Then switch your LFO to a ramp or a saw. And then capture some of that. Okay, part 4 compared to part 3 is just like part 2 was compared to part 1. All you're going to do is switch the input into the sample and hold to pink noise. And then repeat the same experiment and capture it. It should sound something like this. That's the classic filter sample and hold effect. The reason that was used so much is because it's modulating the filter but not the pitch of the oscillator. So you can hold a single note and it stays tonally wherever you want the note to be, at your tonic or your fifth or whatever, but it's modulating the sound. So that's pretty cool. So that's all the initial sample and hold stuff. Now we're going to go to part 2 of sample and hold, where we use the sequencer. We're going to use the sequencer. You're going to use the internal clock, so you will press oscillator on when you want it to play. I would start with the frequency vernier about 4, and I'm sorry, the vernier is below. Okay, the top one here, the clicker at 4, and the one here at about 4, it's not straight up, not like 11 o'clock on the clock dial. Take row 1, you're going to use row 3 or 1. No, don't. Use row 1. And you're just going to set these, make sure that your voltage is in the ×1 range. And then you're going to take an output into channel 1 of the quantizer. the output of channel 1 of the quantizer into the 1 volt per octave input of your VCO. So now, if you just hit play on this and turn this up, you should be hearing a sequence that also, as you slow this rate down, you will hear the filter modulating like it just did, but this will not be synchronized with the speed of the sequencer. It might sound something like this. I'm starting off with the FM attenuator on the filter off, so the filter is not modulating. And now here it is. Especially if you slow the sample and hold down to like 2 or 3 or around there, you'll hear that it's out of tempo and rate with the sequencer. So capture a couple seconds of that, check. Then you're gonna love this. This is cool. Take the output of the oscillator output of the sequencer, plug it into the gate input of the sample and hold, and then move the switch on the sample and hold from internal to external. Now go listen to it and make a brief capture. This is what that sounds like. This is another situation where you need to adjust the FM sensitivity on the filter and the frequency. So as you could hear, now the randomization of the filter frequency is synchronized perfectly with each step of the sequencer, and I hope that you made the mental leap. If you played a standard synth patch from a keyboard that you know how to patch from EMT, and you also fed the gate output not only into envelope generator, but into the gate input of the sample and hold, and also fed the output of the sample and hold into the filter along with the envelope generator using a modulation matrix, you would have a bit of randomization there as well. Here's the last thing with sample and hold. Here we go. So this is what part whatever it is. This is part 6, and it's simple. All you do is instead of feeding noise into the sample and hold, once again, you feed the sample and hold from the LFO. And why don't you set this either to a triangle or a ramp, and then do the same thing. You don't have to unplug this, but for your first recording and capture, set the clock back to internal and listen to it. So it'll sound something like this. So after you capture a couple of seconds of that, and this is the last part of sample and hold, this is cool, you're going to use hard sync. So what you do is you take your gate 1 output and you feed it into the hard sync input of the LFO. So now every time the sequencer is on stage 1, it will force the LFO to reset to the same part in its waveform. Then what you can do is you can adjust the speed of the LFO and the sensitivity of the filter to create consistent effects in what the filter is doing. Could sound something like this. see what that sounds like? Okay, that was all the sample and hold stuff.